Hi everyone, welcome to Chapter 7 material. This is going to be pretty heavily math intensive, but with that said, it's more just algebra. You're given two of the things that you need and then you solve for the third, for instance. It's pretty straightforward. There's some very nice summary slides in there about, I think it's 35 or 36. And then we'll be discussing some basics of consumer choice, which we've already gone over for the most part, but this is introduced again in this chapter. So let's talk about price elasticity. Price elasticity is a very important number. Elasticity, again, is a word that only economists use. But what we're going to measure is when prices rise, how many consumers leave? Do a lot of consumers leave when prices rise by 10%, or just a few consumers leave when you raise prices by 10%? This is what economists measure. So what we might do is we are getting some ideas about what a product's demand curve is, and that will help producers better understand how consumers think about their products and better able to predict what's going to happen if they have a sale. If prices go down, how much more will be sold? If prices go up, how much less will be sold? So that is the idea of elasticity, and we're going to put numbers to it. But the basic idea is that if prices go down, how much do consumers respond to that? And that's what we call the elasticity. All right. So what we're going to do is we're going to calculate this. It's called the price elasticity of demand. It is a percent change in quantity demanded divided by the percent change in price. We are going to absolutely put numbers to it in a little bit, but for right now, write this equation down because you're going to have to memorize it. The price elasticity of demand, again, is a percent change in quantity demanded divided by the percent change in price. So what you can see is that in these word problems here, what's going to be happening is they're going to give you 2 out of 3 of the elements, and then you will solve for the third. So they might give you a part of the percent change in quantity demanded as a part of the word problem. They might give you percent change in price as a part of the word problem, and then you just solve for the number that is elasticity of demand. For instance, calculate elasticity of demand. Suppose that the price of the Ford Explorer rises by 10%, while other prices remain the same, so it's always ceteris paribus in this case. Ford can expect sales to fall substantially by about 30%. So we're going to plug in 30%, 10%, and then we're going to get a measure of elasticity of demand of -3. So we've solved for it. We have 2 out of the 3 elements. We solve for the third. That's the first thing that we need to do in this chapter. Suppose the price of all new SUVs rise 10%. Let me see if I can get rid of this a little bit. There we go. So for example, suppose the price of all new SUVs rise by 10%, and we expect sales to fall to only 5%. So basically we have percent change in price, positive 10%, percent change in quantity, negative 5%, so your elasticity of demand is negative 0.5. Does that make sense? So your elasticity of demand, is it always going to be positive or always going to be negative? It's always going to be negative because every single time your elasticity of demand is always a negative number. And that's the first kind of element besides the equation that you have to memorize, that your elasticity of demand is always a negative number. When prices go up, quantity demanded goes down. When prices go down, quantity demanded goes up. So you have to remember that. So by how much more inventory does SUV dealers need if prices drop 20% during a car sale when elasticity of demand is negative 0.5? So there we're given 2 out of the 3. In this case, my elasticity of demand is negative 0.5. Prices drop by 10%. Nope, not in this case. Prices drop by 20%. So in this case, that's a negative 20%. So basically, what will happen to quantity demanded? It'll rise by 10% because 10 over 20 is negative 0.5. So do you see how we kind of solve for the third? Got it. Suppose a manager of a local water company and you are instructed to get consumers to reduce their water consumption by 10%. What's that? Is that your percent change in quantity or your percent change in price? That's your percent change in quantity. So negative 10% is percent change in quantity. If the price elasticity of demand for water is negative 0.25, how much would you have to raise the price of water? So let's see if I can draw this out and get this baby to work. No, I can't. All right. Oh, there it is. So basically what we've got is your percent change in quantity demanded. Maybe I should just do this. Your percent change quantity demanded is going to be equal to negative 10 divided by your percent change in price, which is X. And that's going to be equal to negative 0.25. What X would solve that? I've got to do this right. Percent change in quantity demanded divided by percent change in price. And that's going to be equal to negative 10 divided by X is equal to negative 0.25. So X is going to be 40%. Does that make sense, you guys? We're solving for 2 out of 3. We're given 2 out of the 3 elements. We solve for the third. And these are all these different types of word problems are going to introduce so that you have to solve for percent change in price. You're going to have to solve for percent change in quantity. And then again, you're going to have to solve for elasticity, that number, elasticity of demand. But besides that, all of the word problems will contain 2 out of the 3. It's not going to kill you. It's not going to be overwhelming. All right, so now we need to decide on how we are going to define elasticity. So for economists, elasticity has a very specific meaning. That is, it is very elastic. It's a high number. It's a big number. It's very elastic if it's a big number, which means that prices go up by 10%, quantity demanded changes a lot more than 10%, right? That's going to be greater than 1. The absolute value of that will be greater than 1. And so that's what we're going to say, what we mean when we say it's elastic. That is, if your elasticity is greater than 1, economists call that an elastic demand curve. And what that means is that when you raise prices, consumers are going to bail like crazy. Now, if you're inelastic, this would be a very small number. So when you raise prices by 10%, not very many consumers are going to leave. That product, that's a really important product, right? You can raise prices like the EpiPen maybe. You can raise prices, but you still have to buy it. Quantity demanded doesn't change that much. That's inelastic. Make sense? So we're going to define different types of products. Some products, when you raise prices, quantity demanded, consumers are going to bail like crazy. In some cases, when you raise prices, not very many people leave. We call that inelastic. So you just have to get this in your head. It is elastic or inelastic. Elastic, a ton of consumers leaving. If it's inelastic, not very many leave. And so different products have different characteristics. If you raise prices by 50% for Skippy peanut butter, people are going to bail like crazy because they're going to buy Jiffy. Make sense? That's a type of product with a high elasticity. A product with a low elasticity, we'll talk about characteristics later, but a product with a low elasticity you may raise a price by 50% and quantity demanded goes down barely any, like the EpiPen. You have to have that. So the EpiPen it's been in the news lately. Basically, the producers of the EpiPen have tremendous market power and they've just decided to raise price. And because Kids need this at school. It's a requirement for daycare, for school, for work. You have to carry these around. They expire after a little while. So every year you need to produce or buy more of them. So when prices go up, quantity demanded goes down just a little bit. They don't lose very many customers. That's inelastic. Okay, I think we got that. All right. So sometimes what we're going to do is we're going to combine these concepts. So first, we have to find what is the number for elasticity, and then second, we define that as elastic or inelastic. So first, the word problem requires us to calculate the elasticity of demand. It says, suppose the price of a Ford Explorer rises by 10%, and sales will fall by 30%. So your elasticity is -3. Make sense? Now, is that elastic or inelastic? All right. Clearly, absolute value is greater than 1. What do we mean by absolute value again? Absolute value basically means that you're taking away the negative sign. Absolute value means that the absolute value of -3 is going to be 3. Make sense? You just kind of drop the negative. I don't know. I'm not a math teacher, but that's kind of what I do. So basically what we've got is we've got an elastic demand curve. Make sense? So we got to combine the equation with the words. All right. In this case, it's an elasticity of demand calculated to be -0.5. So is that elastic or inelastic? Well, absolute value of that is inelastic. It's less than 1. Absolute value is less than 1. It's 0.5, so therefore it becomes inelastic. All right, next key concept. The next key concept that we've got going on here is that we have to plug in points along a specific demand curve. We have percent change in quantity demanded right here, right? And this is what we're going to use for percent change in quantity demanded. It's going to be the change in quantity divided by the average quantity. It's not really percent change because usually percent change is Q1 minus Q0 divided by Q0, right? That's usually your percentage change, but that's not the way we're going to do it. Not at all. What we're going to do is we're going to use the average. We're not going to use the original quantity in the denominator. We're going to use the average quantity in the denominator. And this is a formula you must memorize or have a really good cheat sheet because it's an online test. Yay! All right, so make sure this is on your cheat sheet. Let's see how we're going to implement this. Basically, we have a demand curve, don't we? Trina bakes specialty cakes. She can sell 50 at 7 or 70 at 6. So this is a downward sloping demand curve. It tells your quantity demanded at this price or quantity demanded at this price. Make sense? It's a downward sloping demand curve. When prices go up, quantity demanded goes down from 70 to 50. It's a demand curve, but we don't see it in numbers. They're going to put it in words in this case, but it could be that they're going to give you a demand curve in numbers. You got to be able to do this for both a situation where the word problem is a bunch of numbers or the situation where the word problem is a bunch of words. Kind of get it? All right. So basically what we're going to do is a percent change in quantity demanded. We know that when the price goes down, quantity demanded goes up. So it's going to go from 50 to 70, and then the average of 50 and 70 is we're going to take 50 plus 70 divided by 2. That's your average, right? That's your average quantity here in the denominator. Does that make sense? We're always going to use the average in the denominator and the difference in the numerator. So that becomes -20 over 60, so that becomes a -33.3. Percentage change in price. Price went from 6 to 7. So that was 7, the difference is 1, and the average is 6.5. Does everybody see how we got this, a percentage change in price? We have the difference in price between 6 and 7, and then the average price between 6 and 7 is 6.5. So price goes up, that's a positive 15, and then we calculate elasticity of demand along a specific demand curve between 2 points. That's what we have done. Let me kind of show you that. think it's easier to see this. So here we again have elasticity of demand between 2 points. Before, we were given the words to describe the points along the demand curve, and then we had to apply this formula. That's what we just did. We were given words to describe these points along a demand curve, and then we solved for this. Another way that they're going to introduce this is that they're going to make us calculate an elasticity of demand using this formula, using, like a graphical representation. So here, the price of whatever this is, the price goes up from $1 to $2. Quantity demanded goes down from 110 to 100. So we're going to calculate the difference divided by the average. That's going to be 9.2. And then in price, the difference divided by the average, and that's going to be negative 66. So your elasticity is calculated along a specific demand curve as negative 0.14. And in fact, every single point along a demand curve is going to have a different elasticity that we calculate by, like this. So we can either do it by words, or we can do it looking at graphically, but we still have to plug in all the numbers. The difference in the price divided by the average price. The difference in the quantity divided by the average quantity in order to calculate this elasticity number. All right. So we've got that. Any questions? All right, let's do this. When the price of Pepsi increases from 50 to 60, the quantity demanded decreases from 100 to 50. What is the elasticity over this price range? Why don't you guys try and do that really quickly, and then we'll calculate it. Just put in some numbers. So the difference in price is 10. It goes from 50 to 60. The difference in price is 10. The average price between 50 and 60 is 65. So 10 divided by 65 is your percentage change in price. Or ARC, percentage change in price. All right, and then next, percentage change in quantity would be, the difference would be 50, and then the average is 75. The average between 100 and 50 is 75. So we have to calculate all that out, and we do. Percentage change in price, percentage change in quantity, and it is elastic. Does that make sense? So this clicker question, which came straight from the test bank, the answer would be B, elastic. Work, you guys. So again, we can calculate elasticity along a specific demand curve. And what we learn is that there's a really specific pattern for elasticity along a specific demand curve. So this is the same demand curve. It's a straight line demand curve. And what we learn is that at high prices, you tend to have an elastic demand curve. At low prices, you tend to have an inelastic demand curve. And this is important. We'll learn how this relates to total revenue. Very important for a particular producer. All right. So that's kind of the next concept. The next concept is one that we kind of already went over, is that you got to calculate this elasticity, and in fact, the elasticity differs at different points along this demand curve. At high prices, it's elastic. At low prices, it tends to be inelastic. So how about this one? Along the demand curve, point A is more elastic than B. Point A is more inelastic. Yeah, it's more elastic. At high prices, it's more elastic. At low prices, it's more inelastic along any specific demand curve. So along any demand curve, we do know that elasticity changes. We can have a specific number. We can calculate it. This tells us how responsive consumers are going to be when you change prices. Very important information for the producer. But we can also compare elasticity across different products. So what we've got going on here is that a vertical demand curve, economists think that It doesn't happen. We don't believe in a vertical demand curve. No matter what the price, you're still going to buy that same quantity. Even if it means that you might die from a heart attack and you need this horribly expensive operation. It could be that some people will do it, but also some people are going to substitute out of it and go, no, you know what? It's not worth it. I'm just going to give this inheritance to my kids. I'm going to choose not to pay $2 million for this operation, go in debt for the rest of my life or something. So basically, no matter what the price, you still buy the same quantity. Economists don't think that. We think that at least for some people, they will substitute out of it so that there's at least some negative slope to it. Now, it could be relatively inelastic. So in this case, we are going to be comparing elasticity across different types of products. Let me show you a picture of that. So different types of products have different elasticities. So in some cases, when you raise prices from $4 to $6, a ton of people leave the market. That's a very elastic demand. Remember, when you raise prices, quantity demanded goes down a lot. It's a really big number. It's elastic. In contrast, what we could have is we could have raising prices, but not that many people leave the market. So these are two different products. Granted, the elasticity changes along any single product, just the way that we've talked about, more elastic, more inelastic, but across two different products, we also see two different elasticities. And so that's very important to be able to distinguish and understand that different products have different elasticities. So back to this. So this is a relatively inelastic. When prices go up, quantity demanded doesn't go down by much. At least some people are going to quit smoking, but not everybody's going to quit smoking. Some people will just continue to pay more and more and more and more. This is a unitary elasticity. It's kind of like the percent change divided by the percent change is always the same. That's a unitary elasticity. This is a relatively elastic demand curve. Fairly flat. When you raise prices, a lot of people are going to leave. Demand for Granny Smith apples is elastic, so that if you raise the price of Granny Smith, quantity demanded is going to go down a lot because there's a lot of good substitutes for Granny Smith. Although, not if you're a baker and you know what goes in an apple pie. What goes in an apple pie, you guys? Okay, Granny Smith. That's what goes in an apple pie. You can't substitute that, but it doesn't matter. This guy, he doesn't know how to make apple pies. It's okay. All right, next we've got perfectly elastic. This is a perfectly elastic demand curve, and what that is we're going to talk about that in chapter 9 a lot. It's going to be the perfectly competitive situation, and it's where no matter what, whether you produce a little bit or a lot of it, if you're a big producer or a small producer, you still have to take the world price. The price is given in the market. It's a perfectly competitive market. If you produce wheat, you have to sell at the going price of wheat. If you produce hog bellies, then you've got to sell at the going commodity international price of hog bellies. I don't even think they exist anymore, but you get the idea. All right, so here we have elastic and inelastic demands. All right. So determinants of demand elasticity, availability of substitutes. Anytime you have a lot of good substitutes, when you raise the price, a lot of consumers are going to leave because they're just going to go to a better priced alternative that's easily and well available. So anytime you have a lot of substitutes, you're going to get a big consumer response. It's going to be more elastic. Another determinant, share of your total budget. If it represents a very small part of your budget, let's just say it's not necessarily cigarettes because that can run into some bucks, but let's just say it's like matchsticks. How much are you going to pay for a book of matches? Oh, it goes up from 5 cents to 25 cents. You're at a resort or something, right? So is your quantity demanded going to go down a lot? No. It's just your budget is not impacted. So if it's a really small part of your budget, it's going to tend to be more inelastic. If it's a large part of your budget, then when the prices go up, quantity demanded is going to have to go down even more because it really impacts your budget a lot. So the more easily available substitutes, the more elastic. The smaller the portion of the budget that good represents, the more elastic. And then time. Over time, it's easier for consumers to respond in the longer term. So let's just say the price of gasoline goes up from $2 to $8 a gallon. I don't know why. Maybe Saudi Arabia starts to restrict quantity. Anyway, so price of gasoline goes up. Now, in the short term, can you substitute out of gasoline very easily? No, you can't. You can't sell your car and get a more fuel efficient car in the short term. You can't, I guess you could readjust your schedules if we had any good bus transportation, right? But it's really hard in the short term to adjust your consumption, so it's more inelastic. In the longer term, here we have this price of $8. Oh my gosh, I'm so going to downsize my SUV to a little smart car, right? So in the longer term, you can substitute out of gasoline. In the short term, not so much. So the idea here is availability of substitutes, share of the total budget, and time frame will impact the elasticity of different types of demand curves. So what we see is relatively inelastic is salt, matches, toothpicks, right? Such a small share of our budget. Relatively inelastic is physician services. Very hard to substitute out of all physician services when you've got strep, right? You got to pay. Very elastic, restaurant meals. First thing I do when I'm cutting back is I don't go out to eat. Fresh green peas. Why is that elastic? There's a lot of good substitutes for fresh green peas, right? You get canned peas, frozen peas, etc. Likewise, fresh tomatoes. All right, let's talk about some other things. So typical things that they're going to try and trick you with multiple choice questions, which is not terribly obvious at first, but once you know the trick, you got it. And that is anytime you have an adjective that describes a specific type. This is, which is more elastic, all of automobiles or a Honda Accord, a very specific type of car? Well, clearly, if the price of a Honda goes up, you can easily substitute. So a specific car is going to be more elastic than the group of all cars taken together. Likewise, let's just do another example. What about beef versus steak? Which is more elastic? Steak. Steak is more elastic because it's a specific type of beef. It's a lot easier to substitute out of steak if it goes crazy than it is to give up all of beef. Likewise, Dijon mustard. Yeah. Again, I have trouble substituting out of it, but a lot of people don't because there's so many good substitutes. How about a Sony flat screen TV? Is that going to be elastic or inelastic? Elastic because it's a Sony. It's not all of TVs. It's a Sony. How about college tuition for a senior? What if the prices go up and you're already a senior? Probably inelastic. You'll probably end up paying. How about gasoline? Gasoline tends to be very inelastic. It's hard to substitute out of gasoline right now. All right, how demand elasticity and price changes affect revenues of a product. So basically what we've got is this relationship in general. And this is for a particular product, for a particular producer. There's a relationship about how when they raise prices, how that affects the amount of money that they're going to take in or the amount that consumers are going to spend. One thing I want to start out this discussion with is that total revenue is the same as total expenditure. If consumers are spending, it's the same as producers receiving that money. So in the parlance of these multiple choice questions, total expenditures, the amount of consumer spending, is the same as producer revenues. There's no taxes. There's no difference between what the consumer pays and the producer receives. So what we learn is that if you're producing in the elastic range, remember that when prices are high, that tends to be more elastic. Well, as you lower prices, revenues go up. As you lower prices, because here we're expanding quantity and prices are going down. Here we're expanding quantity and prices are going down. You're actually going to get more money. When you lower prices, you're going to get more money. If you have a sale, you're lowering prices, you're getting more money. If you're in the elastic region and you have a sale, you're going to make more money if you're that producer. Does that make sense? Does everybody see how this works? Versus in the inelastic region, if we're producing down here in the inelastic region, if we lower price, revenues go down. Well, what does that mean? That if you're in the inelastic region and you raise prices, you get more money. That's the EpiPen, right? They raised prices and they got a ton more money. They were in the inelastic region. So this is kind of the basic relationship, is that if you're in the inelastic region, when prices go up, total revenue goes up. If you're in the elastic region, if prices go up, total revenues go down. You can't raise prices. What you can do is you can have a sale if you're operating in the elastic region. All right. So, and if it's unitary elasticity, then it's constant. All right. A recent study on enrollment at a liberal arts college concluded that the demand elasticity is 0.91. What I need to say is negative 0.91, right? Because that would be the absolute value. The administration is considering a tuition increase. Should they raise tuition, lower tuition, keep it the same if they want to maximize revenue? Let's see. What's the relationship between revenue and elasticity? Is this elastic or inelastic? Is that elastic or inelastic? That's inelastic. So we're in the inelastic region. When prices go up, total revenue goes up. When prices go down, total revenue goes down. So what should they do if they're in the inelastic region? They should definitely increase revenue or increase tuition. Make sense? They should raise prices. Good. I think we got it. All right. So this is, I made these. I'm pretty pleased with this. So summary pages. So these are a good cheat sheet because we get to take it online, right? Yeah, you get a cheat sheet. So this is a really good cheat sheet to have because it kind of summarizes all of these key learning points. One is that elasticity of demand is always a negative number. And so you're going to have to take the absolute value of it to make it elastic or inelastic. But anyway, so we learned the equation. We're going to plug in 2 out of 3 and solve for the third. The next thing that we learned is that we can plug in points along a demand curve. And so we can plug those in and solve for the elasticity of demand. Then once we get the elasticity of demand, we can define it as elastic or inelastic. So we did that. Elasticity varies along a single product demand curve. At high prices, demand is more elastic. At low prices, demand is more inelastic. That's along a single demand curve, right? But we can also compare it across different types of products. This one is more inelastic and this is more elastic. When they raise prices, consumers hit them hard. When they raise prices, a ton of consumers leave. That's elastic. And then elasticity of determinants of elasticity, number of substitutes, share of the budget, the longer time to adjust, and then elasticity and total revenue relationships. So these are the key things that you're going to need to know about elasticity of demand. Lots of different clicker questions. It's fairly straightforward. Please let me know if you have any questions, just email. All right, we have another measure. Before we had elasticity of demand, and this is called income elasticity. The income elasticity is defined as the percentage change in quantity demanded divided by the percent change in income. When income changes, how does product demand change? That's what we're trying to figure out. From one low income area to a high income area, from one low income country to a high income country. If we have an expansionary phase and wages are rising, income are rising, what is going to happen to the demand for your particular product? This kind of tells us how consumers respond when their incomes change. So we're going to define something called a normal good and an inferior good. All right, let's talk about an inferior good first. An inferior good has a negative income elasticity, so that when income goes up, quantity demanded goes down. As you get richer, you consume less of these goods. That would be a negative income elasticity. So some types of products are said to be inferior products. That is, when you get richer. All right, take for example, in college, I ate so many ramen noodles. I also ate dried milk in my coffee, right? So what happened once I got my PhD? I ditched the ramen noodles and I never used dry milk again. So as I got richer, my quantity demanded of those goods went down. So there's classes of goods that as you get richer, your quantity demanded goes down, and that's called an inferior good because your income is positive, income is going up, but quantity demanded goes down. So that's a positive divided by a negative. Does that make sense? This percent change in quantity demanded is negative. So a negative divided by a positive is going to be a negative number. So what types of products are inferior goods? Types of products that are inferior goods might be Spam, ramen noodles, dried milk, margarine, bus travel, macaroni and cheese. No way. That is not an inferior good. All right. How did that get in there? That's ridiculous. All right. Let's go back up here. Let's talk about a normal good. So a normal good has a positive elasticity of income elasticity of demand. So in this case, when your income goes up, your quantity demanded goes up. When you get richer, you consume more of these types of goods. So we're going to define a normal good as those that have a positive income elasticity. Normal versus inferior. Normal versus inferior, right? So a positive versus a negative. Excuse me. Drink some water. All right. So now, once we have a normal good, we're going to define it as either a necessity or a luxury. A necessity is going to have a positive income elasticity, but it's going to be less than 1. So let's just say you get a 50% raise. You get a 50% raise, which is a lot. I always like to use extreme examples, but anyway. So you get this 50% increase in income. So what happens? Do you consume 50% more electricity? Not usually. You might consume a little more, right? You like the AC down a little more at night. But besides that, you don't consume a whole 50% more. So in fact, when your income goes up, the quantity demanded goes up, but by less than that full amount. So fuel, electricity, food, you may spend more on food, you may spend more on tobacco, but not the full amount of your raise. You'll go up, but not that by that much. So if EI is equal to 0.6, which is your income elasticity, when income goes up by 10%, demand for the good goes up by 6%. Income goes up by 10, demand for food goes up by 6, not by that full amount. So it's going to be less than 1, but still positive. Make sense? Very important that you get these positives and negatives straight. All right. Luxuries. Luxuries now, when you get rich, you get more of those. You tend to consume more of these types of goods. So for instance, private school, you might get a new auto. If I were to ever get rich, I would get a new car. I always get used cars. I would so get a new car. And so you can see that as your income goes up, you may consume even more of these goods. charitable donations, swimming pools, all of these are called luxury goods. Alcohol is called a luxury good. So as your income goes up, your consumption of these go up by even more than that income. It's greater than 1. So if your income elasticity of 2, then when income goes up by 10%, demand for new autos goes up by 20%. That would be a positive 2. All right, talked about that. So if we're going to kind of take a look at these income elasticity of demand, we have margarine, that's an inferior good, fuel, electricity, food, those are necessities, private education, new cars, recreation and amusements, and alcohol, those tend to be luxury goods as defined by economists. Muriel's income elasticity of demand for football tickets is 1.5. All else equal, this means that if her income increases by 20%, she will buy how much more football tickets? 30%, because 30 divided by 20 is 1.5. Does that make sense? 30 divided by 20 is 1.5. So there we had 2, and we solved for the third. How about this one? If a 10% increase in income induced a group of consumers to reduce their yearly purchases of potatoes by 5%, for this group of consumers, is the income elasticity of potatoes 0.5? No, it's negative 0.5, you guys, because income went up, income went up, and potato consumption went down. So kind of get that idea. That is, they're going in opposite directions, so it's negative, which makes D the correct answers. Potatoes are an inferior good. The income elasticity would be negative 0.5. Very tricky. These questions are kind of tricky. All right, price elasticity of supply. We also can get a price elasticity of supply. Notice, let's see, we have 43, or at least 35 slides on elasticity of demand. Look, we have 2 on elasticity of supply. We had 30 on elasticity of demand and 2 on elasticity of supply. You know what that means? It means most of the clicker questions are going to be related to elasticity of demand in those 7 or 8 very important points that we discussed for the last 30, 40 minutes, right? So that is the key area where you need to spend your time, but bring a cheat sheet for elasticity of supply because the same things apply for elasticity of supply. We can calculate it. Percent change in price divided by percent change in quantity supplied. As prices go up, what happens to quantity supplied? Prices go up, quantity supplied goes up. It's always a positive number, whereas elasticity of demand is always a negative number. Elasticity of supply is always a positive number. When prices go up, quantity supplied goes up. You think I'm talking way too much about positives and negatives? I need you to pay attention because this is the crux of how they're going to get you on the multiple choice questions. Pay attention to the positives and negatives here. So elasticity of supply, it's exactly the same. Percent change in price over percent change in quantity supplied, but it's a positive number. Just like we did with demand, when price rises, producers increase supply by 20, then elasticity of supply is 2. We can solve for 2 out of 3. Just like the demand curve, a flatter supply curve is a more elastic one. Supply is more elastic in the long run. And we can calculate arc elasticity, that is putting in 2 different points along the elasticity of supply curve. So we're going to put in those points and solve for the arc elasticity of supply, just like we did demand. Unlikely you'll ever get that question, but you might. So keep your cheat sheet ready. All right. So that is kind of the hardest part. We've just gone through all those elasticity of demand. You're just going to, I tell you, if you just keep at it, you're going to totally do great on this section because it's math, it's logic. all the parts are contained in multiple choice questions. Just practice it, and it's great. If you have any questions, please email me. I really am available. All right, fundamentals of consumer choice. We've gone over most of this because I really consider it to be an important aspect in Chapter 3. So I covered a lot of this already, and so it'll be review for you for the most part. Principles of consumer choice. Limited income necessitates choice, right? We have to make trade-offs. Consumers make decisions purposefully. We know that. They must make decisions without perfect information, and we have the law of diminishing marginal utility. This was really important. Do you remember the law of diminishing marginal utility? That first cup of coffee, absolutely great. I would pay $5 for that, right? I love my first cup of coffee. Second cup of coffee, it's not bad, right? It's maybe worth $1. My third cup of coffee, I'm jittery. I don't find much value to it at all. We have diminishing marginal utility across all goods. Not just coffee, across all goods. So here we have this law of diminishing marginal utility. As we eat more and more ice cream, my marginal utility of that ice cream diminishes. If I eat too much ice cream, in this case, my 6th unit of ice cream, I get a negative. I'm throwing up. I'm not happy, right? I can't sleep. Anyway, you've consumed too much ice cream here. So the marginal utility along the demand curve, you remember that it's both the price and it is the willingness to pay. So let's kind of go up here. So this is not just the marginal utility. What is your willingness to pay for that first unit of ice cream? You're willing to pay $20 for that first unit of ice cream. You're willing to pay $16 for that second unit of ice cream. You're willing to pay $4 for that 4th unit of ice cream. So you kind of get the idea that on this axis is not just the price, it's your willingness to pay and the marginal utility, the benefit that you're getting from this good as you consume more and more and more. The law of diminishing marginal utility implies that the consumer's marginal benefit and thus the height of the demand curve falls with the rate of consumption. So as we consume more and more frozen pizzas, what if the price is $2.50? How many frozen pizzas will they consume? Will they consume 1 unit? Yes, they'll definitely consume 1 unit because what is the marginal benefit of 1 unit? $3.50. You're willing to pay $3.50. You only have to pay $2.50. Your consumer surplus on that first unit is $1. Yes, you're definitely going to consume that first frozen pizza. How about the second one? Again, you'd be willing to pay $3. You only have to pay $2.50. Your consumer surplus on that second unit is 50 cents. Yes, you will consume that unit. I'm going through this because you really do need to know this. And so just be patient with me. All right, so with the third unit, the price is $2.50. Your benefit is $2.50. Yes, you'll consume it. How about this 4th unit? Are you going to consume this 4th unit? No. Your benefit is $2. The cost is $2.50. You're not going to consume it. So this is where we end up consuming, and this defines our consumer surplus. Do you kind of remember all that? Because you need to. All right. So what's consumer surplus here? $1 plus 50 cents, $1.50. That's what consumer surplus is. We can calculate it using it graphically, correct? We can also calculate consumer surplus when we're given the demand curve numerically. We're not always given it graphically. Sometimes we're given it numerically. And so we have to calculate consumer surplus there too. All right. So what if the price is $1.10? Will he buy his first unit? Yes. Price, it's not just price, remember. It's marginal benefit, willingness to pay. It's not just price. It may say price, but it doesn't mean just price, not to an economist. It's marginal benefit, what you're willing to pay for it. So, is he willing to pay for the first unit? Yes. He gets 40 cents consumer surplus on that first unit. He had to pay $1.10. He was willing to pay $1.50. He gets 40 cents on that first unit. How about on the second unit? Yes, he's willing to pay for it, and he gets 30 cents. On this third unit, is he willing to pay $1.10 for it? Yes, and he gets 20 cents consumer surplus. He was willing to pay $1.30. He only had to pay $1.10. He gets 20 cents consumer surplus. On this fourth unit, yes, he will consume that. He'll get 10 cents. So it's 40, 30, 20, 10, and that makes $1 total consumer surplus, because he ends up consuming 5 units, doesn't he? He ends up consuming 5 units. And so we calculate consumer surplus on that too. Make sense? Do you remember that? So at any given price, consumers purchase where the marginal benefit is greater than the price. Purchase up to the point where the marginal benefit equals price. All right, this is kind of the new material. We've covered most of the other stuff up to now, but this is the new material. All right, I'm not going to prove this to you, but if you take intermediate microeconomics, you can do like a lot of math, and they will prove this to you. That is that consumers tend to, because of diminishing marginal utility, that's kind of the underlying assumption that economists use. But we have diminishing marginal utility, that if we were to solve and maximize consumers' utility, what we're going to do is we're going to consume to where the marginal utility over per unit of price is going to be equal across all goods. The marginal benefit per dollar spent is going to be equal across all goods. You have to know that, especially to solve these problems. So let's just say, for instance, we're consuming 2 products. We know that utility maximization, this is how we're going to predict that consumers are going to behave, right? We need this because this is how we are going to predict how consumers are going to behave. We assume that the marginal utility per dollar spent is the same across all goods. Well, so what if the marginal utility per dollar spent is higher for Coca-Cola than it is for wings? What should we do? Well, if the marginal utility per dollar spent on Coca-Cola is higher than wings, so what we should do, just use your intuition. I can prove it to you, and I will in a minute, but basically your intuition says, hey, should I consume more Coca-Cola or more wings? If my benefit per unit spent is higher on Coca-Cola, consume more Coca-Cola. If it's marginal utility per unit spent is less on wings, consume less wings. And that will make it closer to the equality, right? Here's your equality. If this is a situation, buy more Coke. If we buy more Coca-Cola, my marginal utility will decrease, won't it? Because I'm consuming more Coca-Cola, my marginal utility diminishes. As my marginal utility diminishes, it gets closer to an equality. As my marginal utility diminishes, it gets closer to an equality. How do I make marginal quality diminish? By buying more. By buying more is when my marginal utility diminishes, and that makes it closer to the equality. So we can prove it knowing about diminishing marginal utility, but I think the easiest way is to just say, hey, the marginal benefit per unit spent is higher on Coke, consume more Coke. It's less on wings, consume less wings. When you consume less wings, my marginal utility rises. That brings it closer to an equality. All right, how about this? What if at the current consumption levels, marginal utility of wings over the price of wings is 10 divided by 2, right? Here we're given these numbers. That's 10 divided by 2. Versus Coca-Cola, it's 6 divided by 2. So 5. Marginal utility of wings per unit cost is 5. Marginal utility of Coke per unit cost is 3. What should we do? What are consumers going to do? How can you predict what consumers are going to do? Well, what consumers are going to do is they're going to consume more wings and less Coca-Cola because the marginal utility per dollar spent is higher, consume more of them. Okay, good. All right, let's try this clicker question. This is from the test bank. It says Sally likes both vacation days and fine dining and is trying to decide whether to go on longer vacations or go out to eat more often. Currently, she's paying $100 per day and has a marginal utility of $200 for the last day of vacation. She has marginal utility of $100 and a cost of $50 for fine dining. What should she do? Let's try and figure this out. So marginal utility per dollar spent on vacations is 200 divided by 100 or 2. Marginal utility per dollar spent on vacations is 200 divided by 100 or 2. Marginal utility per dollar spent for fine dining is 100 divided by 50 or 2. So she's already equal. She's so smart. We're going to keep her consumption at these levels. All right, this is a little bit of new material. These are other reasons why a demand curve slopes downward. We know that a demand curve for any given individual slopes downward because of diminishing marginal utility. But across a population as a whole, we have basically reasons why, on average, demand is downward sloping. So, for instance, if the price goes up, some people are going to substitute out of that good, and that's called the substitution effect, because when prices go up, some people are going to choose not to consume that product anymore. So it's relatively more expensive, you're going to substitute out of it. Likewise, if the price of the product falls, it becomes relatively cheaper and more people will substitute into it. It's kind of like when you see a sale, right? You see a cheap detergent, relatively cheaper, you're going to substitute into that this week. The other effect is really important for high income items. And that is, if it's really a huge part of your budget, then it could affect what you spend on all goods. It's because it hits your budget constraint, it hits your income. So for instance, let's just say that interest rates rise. All right, so right now, mortgage interest rates are at historically low levels, 2, 3, 4%. 4% for 30-year loan, that's unbelievable. It's great. So let's just say now, though, that you got an adjustable rate mortgage and mortgage rates rise because the economy is recovering, stuff like that. So interest rates go up and your monthly house payments go up from $1,000 to $3,000 a month. Oh my word, that is a budget buster. That really impacts your household income. So when the price of a good that's a really important part of your budget goes up, you have less to spend on everything else. So you feel poorer. Your demand for everything goes down. So let's kind of get back to basics. As the price rises of this particular good, you feel poorer and your demand for all goods goes down. On the other hand, what if you were paying a huge amount and then the price goes down, you feel richer, then you're going to buy more of all other goods. These are still two reasons why the demand curve is downward sloping. One is that when prices rise, you're going to substitute into relatively cheaper goods. When prices rise, you don't feel as rich, you're going to demand less. So these are both the substitution and the income effect. So if the price of gasoline goes up and Dan now buys fewer candy bars because he has to spend more on gas, is this the income or the substitution effect? Price of gasoline goes up and Dan, he can't afford anything now like candy bars because he has to spend so much on gasoline. This is not the substitution effect because you can't substitute in and out of gas, but it is the income effect. It's B. Does that make sense? All right, consumer choice. One of the important things here is that it's just not all about price, it's also about time. So it may be that I'm going to consume more of a good that doesn't take much time to get. It may be that I will consume less of a good if it takes a really long time to access that. So let's just say it's a demand for vacation. Are you going to go to the Caribbean or are you going to go to Thailand? Well, even if the prices were the same, the cost in terms of time would impact your decision on whether or not to consume a vacation in the Caribbean compared to Thailand. Thailand is a good 27, 30 hours. Caribbean is at most 6 or 7. So you can kind of see that time impacts consumers' choices as well as prices. So keep that in mind. I may pay more on Amazon because it's easier and less hassle than shopping at a local shopping mall. And I probably do that. See? Okay, this is another marginal utility per unit price question. Let's see if we can do this. So what's the marginal utility of jeans per dollar spent? Marginal utility of jeans per dollar spent is 2. 60 divided by 30. What is the marginal utility of t-shirts per dollar spent? 3. Marginal utility of t-shirts is 3 per dollar spent. Of jeans, it's 2. I should consume more t-shirts. C. So basically what we've got is we've got a market demand compared to individual demand. So an individual demand and a market demand, basically the market demand is just a horizontal summation of every individual. So let's just pretend that we have a very simple market for frozen pizza. We have just Jones and Smith are demanders in this market. At a price of $3.50, Jones demands 1, Smith demands 2. So the market as a whole, they demand 3. Makes sense? So the market demand is just a horizontal summation. How about at a price of $2.50? At a price of $2.50 to Smith and Jones, we can sell 6. So the whole market demand is 6. So it's just the horizontal summation. Good? That's it. Total market demand. We can do this graphically or we can do it numerically. We need to be able to do both. So here we have a clicker question. At a price of 12, we got Betty, Julie, Buster, and Allie. At a price of 12, what's the total market demand? At a price of 12, what's the total market demand? Betty's going to buy 120, Julie 16, Buster 4, and Allie 8. So it is going to be 148. Total market demand is 148 at a price of 12. So how about this clicker question? When the price of a good is 20, the quantity demanded in this market would be, price is 20. 114. D is the answer. Make sense? So we have to be able to create a market demand as a horizontal summation of individuals, both numerically and graphically. And we did it. We completed Chapter 7. Please email me if you have any questions. Take care.